Hi y'all, this is Mrs. D, and today we're going to be multiplying and dividing inequalities with rational numbers. So if you missed the last video going over multiplying and dividing inequalities, you might want to watch that first. But today we're going to go over how to do this with rational numbers. So let's go ahead and get started. So first, we want to talk about a rational number real quick. And if you remember, a rational number is going to include positives and negatives. And so the situation today is that if we're multiplying or dividing both sides of an inequality by a negative number, you must reverse the inequality symbol. So let's talk about what this means, and we're going to explore why. So if I start out with 3 is less than 4, we know this is a true statement. Now if I were to multiply both sides by 2, I want to find out, is my inequality true? So if you use the number line here, we know that 3 is in fact less than 4. It's going this direction. Now if I multiply both sides by 2, 3 times 2 is 6, and that is less than 4 times 2, which is 8. So now my 6 is less than 8. So I am still going in the correct direction. If I multiply 3 and 4 by negative 2 on both sides, 3 times negative 2 is negative 6, and 4 times negative 2 is negative 8. Well, if I look here, I have negative 6 and negative 8. So is in fact negative 6 less than negative 8? And the answer is no. The inequality is not true anymore because the negative 6 is actually closer to 0, which means it is actually the one that is greater than instead of less than. So this symbol needs to be flipped in order for this to be true. So whenever you're multiplying or dividing by a negative number, so we multiplied both sides of this equation by negative 2. And since I multiplied both sides by a negative, I had to flip my inequality in order for this to be a true statement. So back to our original process, when we have an inequality, we're still using our multiply and divide properties. Only now, if we're multiplying by the same negative number on both sides, then I'm going to flip my inequality sign. So let's see what this looks like. So now I have x divided by negative 3 is less than 2. So in multiplying here by a negative 3. So now negative 3 divided by negative 3 is still 1. So my x is still the same on this side. Now I have to flip my inequality sign and multiply 2 times negative 3, which is a negative 6. So then I'm still going to find this on my line graph. I'm going to find my negative 6. I'm going to do an open circle because it is only greater than. And then I'm going to shade everything to the right of that. So if I were to take any of these numbers to the right of my circle there, let's go with 6. 6 divided by negative 3 is a negative 2. Is negative 2 less than 2? If I go back to my original equation here. And yes, negative 2 is less than 2, so that does make this statement true. And if I were to plug it in here, negative 2 is greater than negative 6 because it's to the right of it, so it's still a true statement. Let's try another one. So now I have 4 is greater than or equal to x divided by negative 2. Now there's a couple of things here that I have to do because I want my x to be on the left side. So if I want my x to be on the left side, I'm going to go ahead and just rewrite this. I'm going to flip my inequality. Then I'm going to solve. And the reason I want to rewrite it and flip my inequality is because then when I solve by multiplying with a negative 2, I'm going to have to flip my inequality again. But I want that x, or my variable, on the left side. So you can either rewrite it and flip your inequality, Or you can flip your inequality and flip it back, which means I'm going to end up with the same inequality that I started with, only my variable is going to be on the other side. So now negative 2 divided by negative 2 is 1, so I'm left with x on the left side. I'm going to flip my inequality, and then I'm going to multiply 4 times negative 2, which is negative 8 on the right side. So now x is greater than or equal to negative 8. So now I'm going to find my negative 8. I'm going to do a closed circle, and I'm going to shade everything greater than, which is to the right. So let's test this one out and see if this one's true. We'll go back to the original equation here, and I'm going to plug in a 6. If I were to divide 6 by negative 2, I get a negative 3. Now 4 is in fact greater than or equal to negative 3, so that is a true statement. This also works the same with the divide property. If I'm dividing the same negative number on both sides of the inequality, I'm going to flip the inequality sign. So let's start out with an easy one here. So we have negative 3 times x is less than 9. So I'm going to, in this situation, divide by negative 3. Whatever I do to one side, I have to do to the other. Negative 3 divided by negative 3 is 1. So I'm left with x is greater than, because I have to flip my sign. 9 divided by negative 3 is a negative 3. So now I'm going to find my negative 3. I'm going to do an open circle at negative 3, and I'm going to shade everything to the right. If I were to plug in any of these numbers here, let's plug in a 4. 4 times negative 3 is negative 12. Negative 12 is less than 9. So that is a true statement. For my other problem here, I have 8 is less than or equal to negative 2x. I'm going to go ahead and flip it. So now I have negative 2x is greater than or equal to 8. Now I can solve, and I'm dividing by a negative 2. So I'm going to flip my inequality back. 8 divided by negative 2 is negative 4. So I'm going to find my negative 4. I'm going to have a closed circle, and I'm going to shade everything less than negative 4. So now x is less than or equal to negative 4. So in this situation, let's just find one of these numbers here. Let's find a negative 5. 2 times negative 5 is 10. And 10 is greater than or equal to 8, which is what I started with. So let's go ahead and recap our steps here. So for our first step, if we're multiplying or dividing both sides by a negative number, you have to reverse your inequality symbol. If we're using the multiply property and multiplying both sides by the same negative number, then we are going to flip our inequality sign. And if we're dividing the same negative number on both sides, we're going to also flip the inequality sign. If you still need more help after you watch this video, be ready to ask some specific questions. And this is Mrs. D signing off with multiplying and dividing inequalities with rational numbers. Have a great day.